Have you ever gazed at the night sky and wondered if there's another Earth-like planet out there, teeming with life? It's a thought that's likely crossed your mind at least once, as it has for countless individuals throughout history. This enduring fascination and curiosity are not merely products of science fiction. They're deeply rooted in our collective consciousness, a testament to our innate desire to explore, discover, and understand the cosmos. Imagine for a moment the possibility of extraterrestrial life, not just microscopic organisms, but complex intelligent beings living on planets similar to our own. This is the intriguing possibility that fuels the relentless search for Earth-like planets, or as some like to say, Earth 2.0. Scientists, astronomers, and space enthusiasts around the globe dedicate their lives to this quest, using state-of-the-art technology and ingenious methods to peer into the vast expanse of space. So, how far have we come in our quest for Earth 2.0? Let's journey back in time and start at the beginning. The search for habitable planets didn't start yesterday or even 100 years ago. It's a quest that has intrigued the human mind for thousands of years, dating back to the times of the ancient Greeks. Back then, philosophers like Epicurus and his followers proposed the concept of cosmic pluralism. This revolutionary idea suggested that there were infinite worlds existing in the cosmos, some of which could be similar to our own Earth. Fast forward to the Middle Ages, the idea of Earth being the center of the universe, or geocentrism, prevailed. This view, though fascinating, limited our understanding of the vast cosmic theater. However, it was during the Renaissance period that a paradigm shift occurred. A Polish astronomer named Nicholas Copernicus came into the picture. He proposed a model of the universe that placed the sun rather than Earth at its center. This heliocentric model was a radical departure from prevalent beliefs and was met with resistance. But as the saying goes, truth prevails. In time, the heliocentric model became widely accepted, paving the way for a broader understanding of our position in the cosmos. This shift in perspective was instrumental. It sparked the idea that if Earth could orbit the sun, then perhaps other stars could have their own planets too. The 17th century saw the advent of the telescope, a device that would prove to be a game-changer in our quest. It allowed us to gaze deeper into the cosmos, providing glimpses of celestial bodies never seen before. The idea of other worlds, once a mere philosophical concept, started to take a tangible form. As our understanding of the universe expanded, so did our curiosity and our capability to explore. The quest for habitable planets, Earth 2.0 if you will, has been driven by our innate desire to reach beyond our world, to discover the undiscovered, and perhaps to find we are not alone in the vast cosmic ocean. Indeed, the search for habitable planets didn't start yesterday, or even 100 years ago. It started when we first looked up at the night sky and wondered, what else could be out there? As our understanding of the universe expanded, so did our curiosity and our capability to explore. With the invention of the telescope, our view of the cosmos changed dramatically. The telescope, a simple yet powerful tool, allowed us to gaze beyond our planet and peer into the vast expanse of the universe. It was through these lenses that we began to understand our place in the cosmos and ignited our curiosity about what lies beyond our own planetary system. The telescope's impact on the search for habitable planets cannot be overstated. Imagine being in a dark room and suddenly being handed a small torch. The room's boundaries become clearer, and you start to discern shapes and objects that were previously invisible. The telescope was our torch, illuminating the cosmic room that is our universe. As technologies improved, so did our telescopes. They became more intricate, more powerful, and more precise. We were no longer just observers, but active explorers, charting the unknown territories of the universe. It was with these advanced telescopes that we discovered the first exoplanets in the late 20th century. Exoplanets, planets that orbit stars outside our solar system, were a game-changer in our search for Earth 2.0. The first exoplanets we discovered were gas giants, similar to Jupiter and Saturn. They were far from habitable, but their existence confirmed that our solar system was not unique. There were other stars with their own planetary systems. This discovery sparked a new wave of excitement and motivation. If these gas giants existed, then perhaps somewhere out there, so did rocky, Earth-like planets. These exoplanets were discovered using a variety of advanced technologies, but it was the telescope that remained at the heart of it all. Telescopes allowed us to detect these planets indirectly by observing the tiny dips in a star's brightness as a planet passed in front of it, or the slight wobble of a star caused by a planet's gravitational pull. Telescopes gave us a clearer view of the cosmos, but they were just the beginning. They were the stepping stones that led to more sophisticated tools and technologies, propelling us further in our quest for habitable planets. The age of telescopes was an era of discovery, exploration, and a deeper understanding of our universe. It was a time that truly transformed our perception of space and our place within it. The dawn of space exploration marked a new chapter in our quest for Earth 2.0. This new era was fueled by a desire to go beyond our own blue home and reach for the stars, quite literally. It sparked a series of missions that played a pivotal role in the search for habitable planets. Among these missions, two stand out with their significant contributions: the Kepler mission and the Transiting Exoplanet Survey Satellite, or TESS. Launched by NASA, these missions were designed with a common purpose: to identify exoplanets, the planets orbiting stars outside our solar system. The Kepler mission, launched in 2009, was a trailblazer in the search for Earth 2.0. It was named after the 17th century astronomer Johannes Kepler, who is known for his laws of planetary motion. This mission discovered more than 2,500 confirmed exoplanets, and it did so by using a method known as transit photometry. This method involves observing the dimming of a star's light as a planet passes in front of it, a phenomenon known as a transit. Following in Kepler's footsteps, the TESS mission took to the skies in 2018. Unlike Kepler, which focused on a small section of the sky, TESS's goal was to survey the entire sky. And it's been quite successful. To date, TESS has identified over 2,000 exoplanet candidates, many of which are located in the habitable zone, the region around a star, where conditions could be just right for liquid water to exist on a planet's surface. These missions have revolutionized our understanding of the universe. They've shown us that our galaxy is teeming with planets, many of which could potentially harbor life. As our reach into the cosmos extends, we're finding more and more worlds that could potentially sustain life. So, where are we now in our cosmic quest? We're in an exciting era, where technology and human curiosity have intertwined, propelling us further into the celestial unknown. The search for habitable planets, for our Earth 2.0, is more tantalizing than ever. We're harnessing the power of advanced technologies. Take the James Webb Space Telescope, for instance. An engineering marvel, it's set to take over from the Hubble, its powerful mirrors and instruments designed to peer back over 13.5 billion years to see the first stars and galaxies forming out of the darkness of the early universe. With this, we hope to uncover planets that have the right conditions for life as we know it. And we're making discoveries at a pace that was unthinkable a few decades ago. Just recently, we've found planets in the habitable zone of their star, where conditions might be just right for liquid water and perhaps life to exist. But it's not just about finding these planets. It's about understanding them, their atmospheres, their climates, their geological activity. Yet, despite these advancements, finding our Earth 2.0 is no easy task. The challenges are immense, space is vast, and we're looking for relatively tiny planets billions of miles away. And then, there's the question of life. Even if we find a planet with the right conditions, it doesn't necessarily mean it hosts life. We need to develop techniques to detect signs of life. A daunting task, to say the least. But the future holds promise. New technologies, new telescopes, and new missions are on the horizon. And with these, we hope to inch closer to answering the question, are we alone in the universe? The universe is vast, and we've only just begun to explore it. Who knows what we'll discover next? After all, every star we see in the night sky could be a sun to another Earth, waiting for us to find it. So, what does all this mean for us? Well, the quest for Earth 2.0 isn't just a journey through space. It's a journey inward. a reflection on who we are in the grand scheme of things. As we scour the cosmos for a planet that resembles our own, we're also seeking to better understand our place in the universe. Imagine the profound implications of discovering another Earth. It would not only be a testament to our technological advancements, but also a testament to our capacity for curiosity and exploration. It would reframe our perspective, making us realize that we are but a small part of a vast cosmic tapestry. More than that, the discovery of Earth 2.0 could pave the way for future space colonization. It could be the first step towards becoming an interstellar species, a monumental leap in human evolution. As we continue our cosmic quest, we're not just searching for another Earth. We're also seeking answers to some of the most profound questions about our existence.